Okay. Web, we're recording. Okay, so what we were working on yesterday is the composites of functions, right? Where it can be written in any of those different forms. I typically like to write it as the first form unless it gives me one of the other things, but they all mean the same thing, it's just different notation. And then we're remembering we're taking whatever the thing is like on the inside or to the furthest to the right and taking whatever that is and plugging it into the one that's outside of that or to the left of it. Okay, so we're going to do that again for this one here. So we left off on this example 3. Let me grab some pens out here. Okay, so we've got here that we're going to let x be a real number and then let t of x be 1 over x. And g be given by g of x is equal to x squared minus 100, and we're supposed to find the domain of tog or t following g. Okay, so when it's like that, the t with that composite and then the g, we're doing it of just x there because they don't give us anything else. So what that means is we're taking whatever this g1 is and putting that into the other one, okay? So I'm going to use colors again. I think I'm just going to use colored pens instead of highlighters today because it got a little messy with the highlighters. So I'm going to make this t of x one color, and then I'll make this g of x another color here. So I'm taking this g of x and putting it inside this t of x, okay? So I'm going to take whatever this is, put it into this one. So my outer one is going to be that t of x. So my outer one is going to be like the 1 over my x value. And then where that x value is, that's where I'm going to plug in. And I just did those two in the same color. It's harder to tell when I got the pens, but those two are in the same color. So then I'm taking that one that's the inner one, or the one that's furthest to the right, and I'm putting that inside of this one. So I'm going to take that x squared minus the 100 and put that inside of there. Okay? Now in this case, do we necessarily need the parentheses on that? Not in this case. Sometimes we do, sometimes we don't. Like if there was something in front of this, like a 2 or something that we'd have to distribute through, we would need that. But in this case, it's just the same as like 1 over x squared minus 100. So if they just asked us to figure out this part, that would be our answer. What they ask us, though, is what's the domain of that situation. Okay, do you guys remember what domain is? So domain is all of our possible x values, okay? So like how far we can go right and left is basically what we're looking for, okay? So here with a situation like this, there are 2 possible x values that will not work. Any ideas what those 2 possible values are? So kind of has something to do with the 0. So let's talk about this. If I have a fraction like this and it's 1 over something, what can the bottom of this fraction never be? That's the thing with the 0 Aubrey was talking about. So 0, because if it's like this, if I use my calculator and I do anything divided by 0, what's that going to tell me? It's going to give me an error, right? Because can we ever divide by 0? No, so that's a big math rule that we can never divide by 0, okay? So here, if we're trying to figure out what numbers cannot work for this, numbers that make this bottom a 0 would be numbers that don't work for this, okay? Follow me at least a little bit. So what we want to do is we want to think of this bottom being a 0 because that'll tell us which numbers don't work. So what I'm going to do is I'm just going to take that bottom part, set it equal to 0, and figure out what numbers aren't going to work for us. Okay, so like here, if I am solving this out for x, I'd add 100 to each side. So I'd have x squared is equal to 0 plus the 100 is 100. Then when I square root each side, you know, those guys will cancel. X would equal what's the square root of 100? Kids. 10 and negative 10. This is not good for our Iowa assessments this week. Yeah, so that would be 10 and negative 10, okay? Why that's important to us is if I go back here, if I put a 10 in there and square it, 10 squared is 100. What's 100 minus 100? 0, and wouldn't that make the bottom 0 and I can't divide by 0? Yeah, same if I put a negative 10 in there, and negative 10 times negative 10 is also 100. 100 minus 0 would also make that bottom stuff, you know, become 0. And since we can't have 0 on the bottom because we can never divide by 0, that's just a big math rule, it means that those 2 values cannot be in our domain. So what you say here for your domain, you say it as all real numbers. So you remember that symbol for all real numbers where it's like the R with the extra line in it? That stands for all real numbers. So it would be all real numbers except plus or minus 10. Okay, because like I said, if you put those in there, it could not equal those values. And if you went and you graph that, you could kind of see how it has like gaps at those spots. Okay, does that relatively make sense? The main thing is figuring out this stuff and plugging into like the composites there, but they might ask you some other questions like that. So domain is always the X values, range is always the Y values. Okay? All right, so that's it. We probably could have finished yesterday, but with the short class, it's fine to not finish. So you got this book page then for tomorrow. Tomorrow we'll go on to the next section, 8.2, and then we'll just keep working.